Dear friends, a warm welcome. I am going to give a presentation, audio presentation on Introduction to Electrical Engineering. And this is the first presentation I am going to give. In this presentation, I am going to discuss what I had learned and what I had experienced, what experience I had got in electrical engineering, and my opinion about the subject, and how I, during my service as an engineer, how did I encounter engineering, electrical engineering, all these things. All these things I'm going to share, and this is such a first such presentation. And in this presentation, first let me start with engineering. What is engineering? Engineering, usually the normal definition says that engineering is the application of science, right? Then what is technology? Because nowadays we have two types of engineering degrees. Some people give Bachelor of Engineering and some people give Bachelor of Technology, and there is no much difference in the syllabus. That is the curriculum. If you look at the different universities, give mostly some deemed universities or universities give as Bachelor of Technology degrees, and information technology is always given as Bachelor of Technology degree. But some colleges give you a Bachelor of Engineering. But what exactly engineering and what exactly the technology mean? I had already told you that from the standard definitions that engineering is the application of science. Then what is technology? Some people call technology is the application of engineering. Engineering itself an application of science. Then how is difference? In fact, whether the definition clearly explains what engineering and what technology is or not. But the actual thing is technology should always, the curriculum in the technology degree should always focus on the latest technological developments happening in an industry. Say suppose an engineering degree, suppose in engineering degree curriculum we were reading about electrical machines, then obviously there are, first let us talk about only machines, not whether it is generator or alternator. First, electrical machines, what does it means is that the standard, what is a shunt machine, what is a series machine. First, I'm very sorry, in the initial itself I am talking about electrical machines. Just understand there is a subject on electrical machines. In that subject, the different types of machines and its working are explained. If this is an engineering degree, probably I think, suppose if it is to be a technology degree, then they may be teaching you what are the latest types of motors had come in the market or come in the latest applications and how they are being used in the industry. That is what the current technology is. Maybe this can be a better differentiation between engineering and technology, but mostly in the curriculum of many colleges and universities, if you compare, suppose if some institution is offering you a BE electrical engineering and other institution is offering you BTech electrical engineering, actually there is no separate electrical engineering. It is electrical and electronics. It is given as electrical electronics. Later we will discuss this. Let's discuss this. But suppose if we compare BE electrical and BTech electrical, the major difference there, you cannot find any major difference. Usually the total curriculum will be the same, maybe one or two topics. Even the two topics also does not give any relevance of differentiation between engineering and technology. Okay, but this is how I know. This is the little I know about the differentiation between engineering and technology. Maybe technology should teach you and bring you in the syllabus the latest technological advancement happening in that engineering field. And I basically have a question, because I had studied, like you, I too have started studying engineering, and later I got a job in industry. And in my total experience, as a student or as an engineer, I have a major doubt whether engineering can be taught in college or not. Okay, of course it can be taught, the principles, and you will definitely have laboratory classes. Laboratory classes differentiate a subject of practical relevance and an ordinary subject. So definitely laboratory classes are very, very important for subjects which are having practical applications. But still, engineering is an art. It's not a science which you can simply read in a book and you can understand it. Definitely, engineering, because engineer comes with a product. A good engineer develops or improves or innovates a product. The product may be in the invisible form or also in the visible form. It can be in the visible form or in the invisible form. Say a car or a software running which is connecting globally all people. So it can be visible or invisible, but its applications are felt, and it is felt by every people, and its application is there in the world. Engineers make life simple. So the major, my opinion is there should be more lab classes for engineering students. In fact, 50% of the subjects should be in lab. 50% of the hours they spend in the course should be in the laboratory, and 50% should be in the classroom. But of course now, because when we were studying, there were maximum 3 lab classes in a week. Most of the classes are in the classroom only. So this, in my opinion, if you really have an interest in continuing in engineering after your graduation, because there is no compulsion that after graduation you will be continuing in your same field, but if you really have interest to continue in your field, engineering field, then better you should show more interest in the lab classes, and you should, even if you get some free time, and if your laboratory is also free, you should go to the laboratory and try to learn, because lab classes will give you the practical, because that is the major engineering. That is the engineering. Studying also very important, because without principles you cannot understand the applications in the laboratory. So then coming to as an engineer, after completion of my course, I joined in an organization. I had good interest when I was studying electrical engineering. So I even in the summer holidays, the semester leave also, I used to read, not in the point of view for getting marks, in the point of view to learn knowledge. But later on, after joining in the industry, I felt it is the only knowing electrical engineering is not sufficient to be a good engineer in the industry. Even to become a good electrical engineer, you should know all engineering department basics, particularly the mechanical engineering and instrumentation and control engineering. These 2 are very, very important for an electrical engineer, because generally electrical engineering is called, mostly in the industry, electrical engineers are in the services department. The major process or production will be by mechanical or chemical engineers or some other engineers, and the electrical engineers will be providing, they will be the services department, like giving power to their machines and providing switch gears to their equipment. And to read any subject, first we should develop interest. Whether we are continuing in the same field or not, we should develop the interest, because only with interest, even to complete the course, and after thinking of going to some other field also, first the person should develop interest in that subject. Only with interest only, at least with an adequate amount of interest, only he can read and complete the course. But after completion of the course, there is no compulsion that he will be continuing in the same field. Based upon the market requirement or his interest, he may switch his 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 job or his profession. So, as you you might have read in the books that interest is the mother of memory and repetition is the father of the memory. To read and to understand any concept, to learn any concept, you should have interest. Then only you can learn. You should have the interest that what it is and how it will function and what will happen suppose if it wrongly functions. And coming to the subject curriculum, as in normal how we started our mathematics, like first we read about numerals, numbers, how to denote numbers in numerals. Then we had gone for multiplication tables, addition tables, multiplication tables, then algebra, then later differentiation and integration, and finally we had gone to complex mathematical problems. Similarly, in engineering also, first we will be learning about symbols, the symbols that are used in the engineering, that particular branch of engineering, and the theorems and the basic problems, and slowly we will move, because this is how the syllabus is being made. But in my opinion, I had studied. While I was studying, I could not able to completely understand why the sequence of the subjects are being kept, and finally at the end of 4th year, after completion of my course, I understood this is how it should be taught. Because first we started with something without completely knowing where we are moving, as only some part, then later some other part, and finally one part we have learned many parts, and finally why you see the complete picture, we have got the complete subject, total subject, and always while studying every portion of the branch of your engineering, try to go for the practical applications it will have. Suppose if I study electrical circuit analysis, or simple electrical circuits or electrical components and circuits, so that time we can simply check for practical applications of simple circuits. There will be always a simple circuit, there will be complex circuits. Take a simple circuit, how your light, what kind of components, how a light can be, how a heater, or how a capacitor, how a fan can be given, simple modeling like resistor, inductor and capacitors. All these things you can start with. And electrical engineering is a very good branch of engineering, I will say, and it's a very interesting engineering field, and it is the mother of all circuit branches. In fact, this electrical and electronics is a the great advantage in EEE. We call usually EEE. EEE is electrical and electronics engineering, and these EEE students, their major focus will be in electrical engineering only, but related electronics will also be taught, and that electronics is sufficient enough to go or to move to electronics field as your specialization in your master degrees or even in your profession. And that EEE delivers you a great advantage that you can switch over to any specialization in your profession or in your further study. And some colleges, when you go for higher studies, some colleges may restrict EEE students, maybe like giving, suppose if you apply for VLSI, MTech VLSI, or MTech communication system, where there may be only 1 or 2 seats will be given to EEE students. But in many colleges there is no, all over the world, in many colleges there is no such restriction, that only electronics and communication student only will be allowed in communication or VLSI specialization. It's not like that. Electrical engineers are also allowed to join MTech Communication Systems and MTech VLSI. In fact, if in a particular college it is not available, it will be available in some other college. So definitely you will have the advantage of doing any circuit branch master specialization or joining in any circuit branch professions if you study electrical engineering. And in my opinion, in future, this EEE department may be slightly modified, that what we earlier had electrical honors. Similarly, it may come again that only be electrical, because electronics they won't mention. But without electronics, electrical will not function. Because nowadays, without electronics, if you study electrical engineering, that person cannot become a complete electrical engineer. Because electrical engineering nowadays always related with the electronics engineering. Electronics, even the digital electronics like logic systems and communication and computer. Because suppose if you take a power system, or a drive, electric motor drive, all are controlled by electronics. A power system program, real-time program is being written in a computer, and the power system is not only analyzed through computers, it is also controlled through computers. Only the core engineers can write program and use the technology for your own applications. So a computer engineer, if he writes a core engineer, if he writes a program for your power system applications, it will be very easy. Otherwise, a real programmer or a computer engineer, if he writes or if he do it, he may be requiring a help of a core engineer or a resource person for his further work, or for his system integration, or for his during his work he will require the help. Whereas if a core engineer do the program for that, it will be definitely useful. Because nowadays, not only nowadays, earlier also there was some control system, but now, so electrical engineer must be aware of the control system. What will happen to the electrical system when you do this, when you do that, whether it is a stable state or it's a not stable state, whether the motor will run or it will go off, whether the load will withstand or not. All these things earlier they had done with some mechanical control, then later electrical control, and later on electronics control, now then digital control, now computer control. So electrical engineer should know electronics also, analog electronics, digital electronics, microprocessor, computer control, all these things he should know. Then only he can become a complete engineer in the industry. Even electrical engineers know only electrical engineering, he cannot become a complete electrical engineer in the industry. To become a complete electrical engineer in the industry, he should know electronics, adequate electronics, analog and digital, communication, particularly very, very important is instrumentation engineering, control engineering, and computer engineering also. And regarding, I already told you that the electrical engineering branch is majorly a services engineering branch, and mostly they are the services branch in every process industries and in the manufacturing industries. Mostly you can find only process and manufacturing industries everywhere. Only in the transmission and distribution, electrical engineers play the major role, and they are the very, very important person. And the two in the transmission system, when they build the system, like building a transmission wire to the system, and only the civil engineers will be there, because the structure stability, only the height and dimensions of the wire, the clearances from the ground and the dimension of the wire will be given by electrical engineers. Other the structure stability, how to erect the structure, and the erection of the part, everything will be done by the civil engineers. But during the operation and maintenance, electrical engineers' role are very, very important in the transmission and distribution, But you can find thermal power plants or in other power plants, whatever maybe, whether the hydro power plant or a nuclear power plant or even the renewable energy systems. There also you can find power plants which generates slightly more than 60% of the electrical energy to the to industrial and domestic applications. In thermal power plants also, you can find only 20% of the engineers. Only at the end stage, the engineers will be generator operators. There is the boiler operator and the engineers in the boiler operation and the engineers in the turbine operations will be mechanical engineers. Only the engineer in generator operation will be electrical engineer, and which they produce the electrical engineer produce the electrical energy will be stepped up through a step-up transformer, and it will be connected to the switch yard, a big switch yard in the at the side of the thermal power plant, and which will be connected to the grid through transmission lines. And mostly, even in the thermal power plants also, mostly you can find mechanical engineers and you can find chemical engineers. And the civil engineers will be there for providing services and for some civil engineering related work. Mostly thermal power plant, you can find most of the engineers, almost 60 to 65% of the engineers will be mechanical engineers. Even during the erection, commissioning stage also, there will be mostly mechanical engineers, few civil engineers, few instrumentation and control, mostly civil engineers and mechanical engineers, and you can find mostly mechanical engineers, few civil engineers, and you can find some electrical engineers, some instrumentation and control engineers. But it's not number, but it's the system. But everybody is very important. All, including the right from the civil engineer who do the foundation and erect the structures, and the mechanical engineer who erects the boiler and turbine and the generator, and the electrical engineers who build the generation side and who make the electrical portions, and the instrumentation engineer who designs the controls and instrumentation for the operation of all are very important. And even in every industry the situation is like this. All engineers, it's fully a teamwork. It's not about numbers. These many engineers are this many engineers are that. It's not like that. Everybody is important. Maybe some engineers will be small in some industries or in process industries, some manufacturing process industry, but they will be there everywhere. Whether it is manufacturing of so-and-so item, or process of different systems, there may be different process industry, there may be different manufacturing industry, but the service engineering person will always be there. So though his number is less in some places, he will be there everywhere. In that angle, the number will be equalized. And it's not about the numbers, it is about it's like a teamwork. Nothing is independent. Everybody is dependent, and everybody is involved in the production of the product or the system. And every engineer should interact with every engineer. Without interaction and without inputs from the other departments, nobody can work. Suppose a mechanical engineer should know about the structures, and based upon, even in the design stage this starts, based upon the design given by the structural engineer, a mechanical engineer will place his equipment, or even sometimes a mechanical engineer may need some supporting points, and he will communicate that to civil engineer, and he will intimate that to this, through their interaction they may slightly change or even majorly change the design to suit this requirement. So, and suppose in that any instrumentation is to be placed, that will be communicated to the instrumentation engineer and the electrical engineers. And suppose a drive is needed, then the mechanical engineer will communicate that to the electrical engineer. Suppose the control system, a new control logic, a slightly modified or major modification in the control logic, that will be communicated to the control engineer or the instrumentation engineer. It will be a teamwork, and nobody can study or nobody can work independently, and all are interdependent. And for design, erection, commissioning, and even in the operation stage also. And now let us move to the college curriculum of electrical engineering. I just wanted to split. Actually, the very beauty of the curriculum is in every colleges, the curriculum is designed such that you will start with the basics, then basics of electrical engineering, basics of basics of electronics engineering. Because for a triple E, for electrical and electronics engineer, the basics of electrical and electronics and the advancements and major subjects, major concepts, and the advancement in electrical and electronics, that will be further continuing. In addition, you will be studying some civil engineering subject, one subject or maybe two subjects, and mechanical engineering subjects like thermodynamics, fluid mechanics, solid mechanics. This will be taught to you. And in addition, the first year you will be studying about physics and chemistry, which are all very important for your future reference, particularly for electrical engineers. This chemical reactions, which will be very much useful for example, when you study about cells, which stores electrical energy, which provides electrical energy. So when you study cells in the electrical engineering, you cannot go deep into the chemical reactions. You will not have time to go deep into the chemical reaction. That you should have completed during your that first year itself. Even sometimes at college, the school chemical, what you have studied in the chemistry subject, that will be sufficient. And there will be, in some curriculum, there will be English subjects also, and this may not be useful for your regular engineering, but this will be useful for your future anyhow. But now, though electrical and electronics engineering subjects are taught parallelly, I just want to tell you that first electrical engineering, then electronics engineering. So first electrical engineering, they will start with the circuit theory, electrical circuit theory, and the electrical circuit analysis is a subject. I already told you how we started mathematics, like numerals. Then we had gone to addition, multiplication tables, and how we learned how to divide. Then we had gone to algebra, differentiation, integration, then later the complex mathematical problems. The circuit theory will first teach you the symbols, then the major principles, and the components, major components in the electrical engineering, and basic principles and the theorems. All these things will be taught in the circuit theory. Then we will be moving to electrical machines. Electrical machines, it is usually taught in two parts: electrical machines 1 or electrical machines 2. In the both parts, usually they will be separate. They will be doing separate. Normally, it is separated. Like electrical machines part 1 will purely deal with DC machines. Electrical machines part 2 will purely deal with AC machines. In both the things, generator and motor will be combinedly dealt, because generator and motor are ulta. If you provide electrical energy to an electrical machine, it will act as a motor. If you provide mechanical energy through a prime mover, it will generate electrical energy. And control, then next major subject of electrical engineering is the control system. But control system is not an independent subject. Control system That too in the modern control systems, you should know about electronics, instrumentation, and a microprocessor, digital electronics, and computer control. Because control system integrates everything. Because it is about in which the control logic is implemented. It might have been implemented in a simple mechanical equipments, through mechanical equipments, or it might have been implemented in electrical equipments or electronics, or in through a digital logic. First analog electronics, maybe in analog electronics, or maybe in digital electronics, or the logic may be a digital logic implemented through computer, and there may be analog signals also, digital logics to switch on and switch off, or the analog signals to modulate or to give continuous variation in the system. So control system is a next major subject in electrical engineering. Then machine design. Machine design is very important, but nowadays I did not have any practical experience in designing machine, because I did not work in such field. But machine design nowadays is of it always goes with the empirical approach, because people will start with one thing. Suppose in the initial machines there were more harmonics, there might have been more they might have not achieved the complete perfect output what they have expected. Then slowly they will change in the design, and slowly they will come out with the latest product. This latest product may be happening in two ways, like changing in the own system, or providing an additional system like controls given to that, or innovating a new product, or combining this product with another product. It may be happening in any way. So machine design is the next subject we will be designing. Then power system analysis is a very, very interesting subject, power system analysis. The full circuit theory applications, you will find it in the power system analysis. And before power system analysis, parallelly you will be reading about network analysis and synthesis, because network analysis and synthesis and electronic circuit theory both are very, very important for power system analysis. The next subject what we will be studying is transmission and distribution, maybe in parallel with power system analysis, and protection and switchgear. Then some electives which are all very important to your engineering branch. That means the electives I am talking about only the electrical related electives. There may be some management electives, there may be some electives which you can go for other departments like communication or electronics engineering. So I will generalize that in electrical engineering you will be studying about, generally if you speak, you can say circuit theory, analysis and synthesis, that one part, and the control systems what you are reading, that is one part. Control system is not only an electrical, without electronics, analog and digital, and communication, instrumentation and computer, you cannot get a complete picture of the control system. That too particularly in the industry. In the industry, control system applications will be more, but that is only possible when you know the complete control system, like control system concepts, then how it is implemented with the mechanical equipments, electrical equipments, analog and digital electronics, and microprocessor and computer control. Then comes first I talked about the major electric circuit analysis, network synthesis and analysis, and next is the control system. Next is the electrical machine, third is the control system, and fourth is the power system analysis. I will have power system analysis, and generally we can say power system, because power system comprises of power system analysis, transmission, distribution, protection and switchgear. You can combine all this in the name of power systems. And one more important branch is instrumentation. instrumentation engineering. And then coming to the electronics, in electronics part, first you will be studying about electron devices, then electronic circuits and analysis, then these two, the electronic circuit and analysis, you will be reading about the analog electronics. Then comes the digital electronics. Digital and electronics are very, very important because in the real world applications, you can find digital, the nature is like both the digital and analog will be combinedly present. Suppose if you are automating a door, suppose a door should be opened. How to open? First, whether to open or not, that signal has to come. That is a digital signal to open the door. And next, with what angle it should be moved. It is a continuous. Suppose it should be moved to 70 degree or 60 degree. That means it's a continuous signal. Okay. So, and suppose a fuel valve is to be opened or not. That is a digital signal. And how much it should be opened and how much it should be closed, that is an analog signal. At some places only there will be a digital control will be there. At some places there will be digital, some places only analog control. At some places there will be combinedly digital and analog signal will be there. And next is the microprocessor and its applications. Very, very important, particularly for people, those who wants to have a profession in the electronics field and in the electronics field and in electronic system development. This subject is very, very, very important. And computer architecture also you'll be studying. But computer programming and programming languages, you should know whether suppose you may get a job in software related software related industry, or in embedded system development industry, or in electronic system development industry, or in your core branch. Suppose you should know computer algorithms and computer languages for writing a program for not only analysis of a power system but also to control the power system in the real time. So I'll be discussing these subjects later in detail, only with practical relevance, because I'm not going to teach you any formulae or any problem, maybe problem, real world problem, something what I know I will teach you, or sorry, I will tell you. But I'm not going to give you the problems, numericals, not formulas in specific. I'm not going to tell you. And thank you for listening. And I will subsequently upload other audios. For the subjects in detail. Like suppose I'll be in detail talking about circuit theory, electrical machines, control systems, machine design, power system analysis, transmission, distribution, protection and security. Similarly, protection and switchgear. Similarly, for electronics subjects, electronic devices, circuits and electronic circuits and analysis, digital electronics, microprocessor and its application, computer architecture. So keep listening. Thank you very much for listening. Dear friends, here I want to tell you that I had authored a book titled Life is Like a Sweet Onion. Please read this book to encourage me to write further. This Life is Like a Sweet Onion book will definitely change the outlook of your outlook on life. And Life is Like a Sweet Onion is available in Amazon.com. Read Life is Like a Sweet Onion. Thank you very much.